My name is Jason Ehlenfelt, and I will be doing a presentation on de-obfuscation. The code samples and information presented in this PowerPoint are from Chapter 12 of the Malware Analysis Cookbook. So, what exactly is de-obfuscation? Well, the Merriam-Webster definition of obfuscate is to make something more difficult to understand. So, therefore, de-obfuscation would simply be the process of making something easier to understand. There's three main types of obfuscation we'll talk about today: encoding, encrypting, and packing. Encoding probably is the simplest of the three and includes XOR and base64 encoding. These schemes are easily reversible and do not require a key. Encrypting, however, comes in two flavors and does require the use of at least one key when dealing with symmetric, and two in the case of asymmetric, which uses a private and public key. These are harder to beat as you actually need the key in order to decrypt them. The last type involves the packing of executables to hide the details of what it is meant to do. The first of the three we're going to talk about today is encoding, which is fairly commonly seen. This poses a rather large question, though. If encoding is so easy to beat, why would anyone use methods such as XOR or base64 encoding? Well, the fact is that they're very simple to implement, don't require a special language, as they're supported by most languages out there, and they don't have a whole lot of overhead, while still doing the job of hiding whatever they're supposed to protect. Well, at least from a cursory inspection. The basic theory around decoding XOR is that when you XOR a bit pattern that has already been XORed using the same operand as the first time, it reverses itself, leaving you with the original pattern. The three types of XOR encoding we'll cover are single byte XOR, 4-byte XOR, and rolling XOR. We'll briefly cover brute forcing XOR as well. Included in the DVD that comes with the book is a Python script called XOR Tools. This script has many functions relating to breaking XOR encoding, and the first one we'll talk about is used to reverse single byte XOR. Single byte XOR uses a single byte, as you might suspect from the name, and applies it to every byte in the original pattern. Unfortunately, using only one byte means that the number of possible keys is very low, leaving this vulnerable to brute force attacks. To combat this, a 4-byte XOR can be used, which applies all 4 bytes of the operand at a time until there are no more bytes left in the original pattern. This small increase in bytes brings the grand total of possible keys up to a much, much larger 4.2 billion, making it much more secure, relatively speaking. The third type of XOR, rolling XOR, uses a variable length key and applies only one byte of the key at a time. For example, with a 4-byte key, it will apply the first byte of the key to the first byte of the pattern, the second byte of the key to the second byte of the pattern, and so on until it uses the fourth byte of the key on the fourth byte of the pattern. At that point, it starts over again using the first byte of the key on the fifth byte of the pattern. It will continue this until no bytes remain in the pattern. Finally, XOR encoding can be brute forced so long as you have a string from within the original pattern. Without this, though, the computer just can't determine when it's hit the correct key. This is the code included in the xortools.py script on top. Below are the commands used to reverse an actual bit pattern. The first line is simply importing the correct part of the script. The second line takes the bit pattern from a stored file and places it in the variable inBuff. You can also just enter in the bit pattern manually if you like. The third line is opening a file to write the decoded pattern to. Once again, you can print this to the terminal if desired. The fourth is where the magic actually happens, though. This is where the single byte XOR function is used. The first argument passed to it is the pattern to be decoded, and the second is the key used to encrypt the file. After this is done, all you have to do is open up the file, and there's your decoded pattern. Once again, the code for the script is on top, and the commands used to run the script are below. The first line is, once again, importing the correct part of the script. This time I chose to print the output directly to the terminal, however. The arguments for the 4-byte XOR function are the same as before, the first being the pattern to decode, and the second being the key used to decode it. And last but not least, a line to print out the decoded pattern. Same as before with the script on the top and the commands below. The commands used to decode rolling XR are pretty much the same, with the one difference being the second argument. In this case, a string has actually been provided as the key instead of a hex value. Same end result though. When brute forcing XOR encoding, strings must be provided for the computer to search for as it decodes each possible key. Without these, the computer wouldn't know what to look for and would never realize when it hit upon the correct key. In the lower box holding the commands, you'll notice that a number of the strings are being placed in a variable called plaintext. These are the strings that the script is going to search for. This time, the command to run the script requires a few extra things. First is that it has multiple outputs, and second is that it takes the plaintext variable holding the strings to search for, instead of the key as the second argument. The lower three lines are simply checking to see if a match was found and printing the results out if one was. Now, you wouldn't want to have to manually decode every packet or file that comes through your system, so a handy little script is provided in XOR tools. This script is called the Get XOR Permutations, and can be used to create rules for Yara so that you can tell it what to look for and let it loose, as it can run through that massive data coming in much more efficiently than a living person could. As you can see, the command is rules.write yaratize, and then you put the name as well as get perms with the string that you're looking for. Decoding base 64 is pretty straightforward for the most part. However, there can be small variations in the encoding scheme being used. Using these commands, you can change the last two chars as well as the character used for padding the end of the string. Sometimes you may run into a custom encoding scheme where, for example, the alphabet and numbers are in reverse. At this point, you will have to write your own decoder for it, as the XOR tools script was not written to handle this. However, this is fairly easy. Just find a encoding script on the internet and just modify it as necessary. This is the end of my presentation, and I hope you've all enjoyed it. All of my code snippets and information came from Chapter 12 of Malware Analyst Cookbook and DVD, and the definition of obfuscate came from the Merriam-Webster Online Dictionary.